Okay, let's go over some examples. Number one, number of aces in a bridge hand of 13 cards when drawn from a 52 card well shuffled deck. Usually the first thing that gives away whether something is binomial or hypergeometric is whether it's done with or without replacement. And hypergeometric is done without replacement. And in this case, because you're drawing 13 cards at the same time or drawing one card at a time 13 times, but you're not putting any of them back, it is without replacement. So this one's probably a hypergeometric, but in order for it to definitely be a hypergeometric, we need to be able to identify the value of little g, big N, and big G. Without that information, we can't use the equation. So let's see. We want to know the probability of getting G good elements. The good elements are ace cards from a pool with N total elements. So 52, G of which are good. There are 4 aces total in the 52 card deck. So we know G and we know N. And for any value of little g, we can calculate the probability of that many aces being in the bridge hand. So number one is hypergeometric. Number two is the number of red cards in a 5-card hand. Let's say this is also from a 52 card well shuffled deck. So similar to number one, we are not doing replacement, right? You can't pick the same single individual card more than once. Once you take it, you take it. And we're pulling 5 of them out. So that's without replacement. And we want to know the probability of getting G good elements. In this case, good would be red. And from a pool with N total elements, 52, again, G of which are good. Half the cards in a deck are red, so G would be 26. Okay, number 3, pick a random number between 0 and 9. Repeat this 20 times. The number has to be an integer. I forgot to include that. And we want to count the number of odd numbers. In this case, the result of one trial has no effect on the result of any other trial. So the second trial is not determined by the result of the first trial. And so this would follow a binomial distribution. And in this case, X is the number of successes, like success being defined as getting an odd number. And you are counting the number of successes, right? Okay, number 4 is you are flipping a coin 10 times. Let's say this is a fair coin, so you have a 50-50 chance of getting heads and tails. The number of heads is definitely the number of successes in 10 trials, and regardless of what you get on one flip is unaffected by whatever you got in a previous flip. So they are independent or with replacement success failure trials, in which case this is a binomial distribution. So yeah.